Hello, how are you? Uh, Welcome to another episode of Wing Zero Symphonics. Welcome to a period where we're combining a bit of the more down to earth, conversational knowledge, memory, and experience sort of look into things and an inquiry together as to when the observer is observed. Okay? And so on this episode, we are going to look into physics. We're going to look into, in particular, this book here, Space, Time, and Quantum. An Introduction to Contemporary Physics, by Robert Mills, who is one of the physicists that the Yang-Mills theory is named after. And that has to do with gauge theory. And so, to preface, the reason why someone like myself would want to read an introduction to contemporary physics has to do with having been thinking for myself as to the fact that the observer is the observed. And it's a fact that only oneself can discover. It's not a fact that can be brought about by anybody. Only oneself can come to that fundamental truth. And if one does come to it for oneself, that level of honesty then allows for an organizing principle in daily living. For who? For the human being. Just the human being. And the human being is a verb. It's an action. Okay? So I found that Krishnamurti would get together and inquire together on these topics with a physicist named Dr. David Bohm. And Dr. David Bohm, okay, he was able to, in his own scientific work, really come upon a discussion between the inner and the outer, or the observer and the observed, and the interplay between the two, not only for theoretical physics application, which generally people are going to assume that has to do with engineering, technology, all sorts of good stuff, as well as perhaps the physicist's role in helping shape a fundamental change in the human consciousness, in the human being, and as a result, in human society, so that we don't blow ourselves up with nuclear weapons, and so that we may continue to discover all that physics has to offer, okay? That's pretty serious. And I think today, a physicist, one of my favorites, Dr. Jack Sephardi, could concur that it is critical to take very seriously the work of Dr. David Bohm. Okay? I met Dr. Jack Sephardi. He wasn't supposed to be there. And he discusses at length notions of synchronicity. Okay? So maybe it was a synchronous moment. And one of the things that he was able to tell me and a crowd of people was that when I asked him about the role of quantum gravity in some of his equations that deal in an application as to engineering, okay, that's safe to assume that that's what it was about, but Mr. Sephardi is far more simpler and far more keen on what the fact that time and space is relative, or that the observer observed, means for the human being. And he did tell me one thing that I could share, okay, because I'm sharing this is what my interpretation of all that is. We discussed at length a few physics kinds of things, but I asked him about the role of quantum gravity, and then perhaps aspects of string theory maybe making their way into the reality of this application of physics. And he told me he worked on what today is a theory which has sprouted my favorite and what I believe is the leading candidate for the next stage in physics, which is the holographic principle, ER equals EPR, having to do with wormholes on a large scale, roughly speaking, right? Remember, I'm not an expert in any of this, so I'm not coming to this as knowledge, memory, and experience because of knowledge, memory, and experience. It's filtered through the fact that it's filtered through choiceless awareness. And so what becomes relevant is the practical day-to-day basis living as a human being. All right, so anyway, he told me that I can quote him on this. He says that I have a psychic connection with another one of my favorite physicists, okay? And his name is, at this moment, oh man, what's his name? Damn. What's his name? He knows him as Lenny. I know him as Dr. Leonard Susskind. And they worked together, I think it was Cornell, and some of the beginning stages of string theory, of ER equals EPR. Jack had been involved, Mr. Sephardi had been involved in it somewhat, but what it is today is certainly far out from where perhaps Mr. Sephardi's involvement was in. So, one of the aspects of, so this is that keen interest in physics, right? So this is a few decades now that I've been looking, learning, and researching and filtering. Okay, filtering, a Jeet Kune Do practitioner would say filtering through the Jeet Kune Do lens. But we need not reference Jeet Kune Do in every single video that I do. All right. Instead, you can just keep it to physics, although what is the martial art besides a largely physical maneuvering and aspect, huh? But anyway, we're not going to separate the mental and the physical. We're not going to do that, not on this episode. You can watch many different sorts of physics episodes, ranging from the big ones and the science communicators to the small ones. It's going to be knowledge, memory, and experience, and the battle between all of that limited information and getting to a conditionally logical point. Okay, and that's great for applying it to how tall a building's going to be and whether the gravity's going to this or that, and okay, or running from here to there, how fast it's going to go. Okay, so since we're not separating the mental and the physical, then we're going to run into a difficulty which the next stage in physics will resolve for. Now, am I working on that next stage of physics? I'm not. No. Do I often think, man, wouldn't it be cool to be able to really get down to this? All right, discuss this at length. All right, look into it. And I don't got the chops. I don't got the mathematical chops. By the time I was venturing into my teen years, my discipline began to wane. And we can go into why, but how about a snapshot of a young American kid playing video games? And one of these video games has the best physics, not only in terms of its story and plot, but in terms of its gameplay. Metal Gear Solid. All right? And so, back to this book here, Space, Time, and Quantum. Is it not the case that when it comes to complexity, a complex problem, that a refinement to it is evolution? And at the same time, it could be seen as, simplicity can be seen as primitive. Without complexity, this primitive thing or notion is incomplete. And one could see it either way, can we not? But if we refer to the former limited observation, right, one half of it, think of perhaps some sort of machinery, engine of some sort that takes 26 steps to produce. And in engineering evolution, it'll take 25 steps and 24, 23, until we get to the problem that the next stage of physics will resolve for. It'll go from 2 steps to 1 step. Okay? 1 step to begin and to end. Okay. So simplicity then. An introduction to contemporary physics. After law school, right? So I am a lawyer by trade, and I enjoy practicing law, and I will enjoy even further as in due time. It's going to take some time. I want to carve out a pathway on my own terms into space law and policy, the future of the practice itself when it comes to law and technology, and what the future of technology and science imply for our understanding of legal precedent, legal systems, all right, and fairness, justice, order, sanity, intelligence. Okay, these are all the things that a lawyer in the law is supposed to safeguard, supposed to protect and ensure. So we could see, okay, it's a difficult thing. It doesn't quite pan out. It has never panned out for the history of humanity. The manner in which it's supposed to. The manner in which the human being, when it digs down deep and asks itself, why can't order reign? Why can't order and freedom reign simultaneously? Isn't there a way? It seems that order and freedom are two separate things. All right, so we're getting down to from two to one. Okay, which means, is there an order which brings about freedom? Is there freedom which brings about order? Not two separate things. Okay, so that's how I'm looking at physics, from that desire to filter, to gather what it is that could be critically applied. Okay, so an introduction to contemporary physics. Now, contemporary, okay, is a funny word, because this is a book from 1994. Okay, it's about 3 years old. Contemporary meant 1994. Now it's 2024, so it's been 30 years since the contemporary notion of physics. And like I mentioned, we've got different routes physics has taken. The particular strain of which is most calling to me has been the string theory, holographic principle, UR equals UPR, celestial philosophy. That's not to say there isn't a splintering of physics, of abstract theories which cannot be experimented on. A whole range. All right, anywhere in there. What people are looking for is the theory of everything. But before we get there, we come back to the introduction to contemporary physics. Now, this deals in the very end of classical physics and the very beginning of quantum mechanics, which is all experimentally validated. Okay, and it goes into, it touches on some of the, so we go into math facts, Newtonian mechanics, okay, as appendixes, right, which are all things that if I were to have to take an exam on, I could not begin to really do as such. Any trained physicist will be able to, with enough of a refresher now, go ahead and get into trigonometry, vectors, analytical geometry, derivatives, integrals, the indefinite integral and the definite integral. Okay, I cannot. But what this book here is intended to be, it says, you know, this is for first-year college students, as well as other interested readers. It assumes some background in high school mathematics, but no prior to exposure to physics is necessary. Elements of classical physics and calculus are introduced in the book where needed. Okay. All right. So that's clear to me. It's needed. It's needed. It's also needed college level mathematics, geometry, algebra. It's also needed for the Air Force officer qualifying test. All right. And there was a period in time where I was intent on furthering my application. I'd done a pre-qualification form, and they said, look, because I have some waiver kind of stuff that would need to be processed, and the recruiter said, let's give it a shot. Of course, he doesn't know whether I'll receive a waiver or not, but it seemed from his estimation, I mean, he didn't say, look, just forget about it. No. And it's very reasonable. I put, as a lawyer, I explained and was completely honest, and it's reasonable to suggest that perhaps on taking a Air Force officer qualifying test and scoring well enough on college level algebra and geometry, that my application could be successful. All right, although it's a 5% chance because I do not have a STEM degree. Okay, so that's a little frustrating on some levels, because we're entering into one of the challenges that the Space Force and civil society are facing, is the challenge of AI integration, which is ethical and maximizes efficiency and order and intelligence and the like, right? So between the two. And already the 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 basic LLM, the ChatGPT, can generally give you college level algebra and geometry. So if need be, some situation arose where it was like, oh man, I really got to figure out a linear equation. I got to figure out a quadratic equation. I got to figure out the circumference in something. I got to figure it out. Well, I know to ask the right question. You see, I'm in the ballpark. And unfortunately, if we were stuck on the side of the road or something like that, we're stuck. But I can ask the right question, and they'll be like, okay, this, and that, boom, boom. Then we put it together, bam, 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 and we're good to go. The car runs or something like that. There's applications of all that. All right, but now we're talking. Eventually, what's going to be necessary is what about sensitive information that comes through in quantum equations, quantum mechanical expressions. Okay, so now we're mixing in the human element of intelligence, of what purpose this quantum mechanical equation is being sought after, which could be of a serious degree of a life and death situation. And so to be able to be equipped to understand what's going on and the like, that's pretty cool to me. All right? So, introduction to contemporary physics. I had around 2021 or so, began watching the Leonard Susskind Stanford lectures. So these are really cool lectures because it's Leonard Susskind, right? So it's going to be a good time. All right, we're going to have fun with this. And they're meant to be simple looks into, let's say, we step into the shoes of Einstein. We step into his shoes, and we for a moment forego the myth and the legend, and we ask ourselves honestly, we look for ourselves at the simplicity of, for example, which is found here. And I'm not saying that some of these aspects of simplicity, let's say, were not found in other areas of physics at the time, which were also profound. But see, we're looking at, where's the experiment? Mr. Susskind had put it really, really nicely. I'm sorry if I can't find it for you right now. But it has to do with some of the questions Einstein asked himself. I should know them. And then applying it to a coordinate grid and using algebra and geometry. Almost, don't take it from me, but apparently from what I understood, it was some of the more simpler aspects of math and that reveals something that was, and it was able to resolve for something unusual. There was something that didn't work. It didn't fit classical mechanics when it came to gravity that just couldn't solve this one problem. It just, once you put it over here, it had to do with light and time. And it just doesn't, how the heck do you? And then Einstein was able to counterintuitively. And so is there a simplicity which is so simple it's counterintuitive, like on a daily basis, that letting go will bring about a whole solution? Something like that, right? And so this book goes into that. The Stanford lectures go into that. I'm looking to actually dedicate time in getting through this. And there are questions. There are problems. There are the speed of light now defined to be exactly this. What is approximate relative error? Okay. It tells me to look at certain appendixes. Gives me a few clues. Relative errors. Error expressed as a fraction, percentage, or actual value. Okay. And it breaks it down. And if I'm serious, and I am serious about what it is that I discussed here, I'd like to take the opportunity that is presented on the internet, on the computer. So on the computer, on the internet is a webpage, and the webpage is linked to a school. And there's an offering of education in physics and some opportunities in physics. Now, it's highly limited, highly competitive. But what stood out to me about these opportunities are that they're beginning to gear towards being okay with letting knowledge, memory, and experience fall away in relative time and space, where fixed points, the most classical of classical notions, a fixed point, for 100 years, right? Contemporary physics, right? That was another point I was gonna make earlier. From like 1909, or from like the early 20th century, is when we experimentally validated all of this. That the degree of simplicity that the next stage of physics requires is an action of a depth, to be able to actually perceive the ending of two for oneself. The ending of two, right, where there's a division, the ending of two, could be the entirety of general relativity and the entirety of quantum mechanics. The ending of the separation between the two. That perhaps it's worthwhile exploring those with a perspective, or rather a freedom from perspective, such as the one found here. I don't know. But I will say that physics, like the other industries that I've found myself in, I'm looking at it through the lens, I guess, professionally, as things stand now, which we're tied to a profession. You are this, you are that, you must be this, right? Which negates the freedom that a human has to look for oneself and see how it's all Kali, as my martial arts instructor would say. It's all Kali, so if it's all Kali, then how come there cannot be an interconnection, interrelatedness, a through line, an integration, a symbiosis, an absorption, all right, a completeness, a wholeness, so the fragmentation of society comes to an end, all right? And I've been able to discuss with my favorite physicist, who is a millennial like myself. And it's about one of the only professional people in these industries, between physics, arts, entertainment, all right, law, politics, and martial art, I'd say. One of the few millennials that I'm really impressed with. At least a millennial who's well known, right, in their field. All right. And so through getting to know them and them explaining things, not to me, but in their work, about, and seeing for myself, physicists argue, debate, the role of money, right? The role of money in the matter, when physicists really are hungry for a keen understanding of reality itself. That's what a physicist really loves. And then things get difficult when it comes all bogged down by money and the conflict over whose theory and what funding, what direction, all right, in relative space and time, what direction, right? For a physicist, it must be maddening. So that's why it's very important then to introduce these physics principles as a fundamental way and organizing principle for the seemingly inevitable hold that money has on the human being and the way in which we organize society. So I guess that's about it. If you're interested in physics, this book is pretty cool. If you're interested in physics, you can check out the Leonard Susskind videos. And let's keep it simple.